Hello everyone. This new tutorial is dedicated to TopChem2 and its graphical interfaces. Today, we will start with a simple example using standard QTAIM and ELF calculations. We begin in beginner mode, which is the simplest mode for running calculations. First, let us briefly describe the interface. You can see several sections. The first section gives the location of the TopChem2 executable file. You can select any location or any directory on your computer. The second section is dedicated to input files. Typically, you can load a wave function file. Here, I select an example based on the ethylene molecule. First, you can check the wave function file using this button. You can see some information extracted from the wave function file. For example, we see 9 molecular orbitals, together with their composition in terms of atomic orbitals. We can also see the molecular geometry. Here, we have a restricted closed shell system. With TopChem2, it is also possible to use a cube file directly as input, instead of a WFN or WFX file. For example, you can specify a cube file for the electron density. By default, the level of theory is set to restricted. You can also select unrestricted, restricted open shell, or natural orbitals. After that, we can display the structure directly with View Input Structure. Now, the molecular viewer opens and displays the structure. Please see the dedicated tutorial for a more detailed analysis using the molecular viewer. We can now set up the TopChem2 calculation. First, you can directly modify the number of processors used for the calculation. Then, several one-density functions are available. You can also choose the name of the main output POP file. For a clearer display, we can hide the first two sections, the executable section and the input section. Now, only the main calculation section is shown, together with the console. In this area, we can see the command line used for the TopChem2 calculation. You can also modify this command line directly, if needed. However, predefined presets are available for most calculations. Today, we start with a QTAIM calculation. Just click on QTAIM. You can see that the selected function is automatically set to the electron density. Then, you can run the calculation by clicking the green button. Good. The calculation starts correctly. The information usually displayed in the Ubuntu console is now shown here. The calculation is now finished. We can go to the Results and Visualization section. Normally, the name of the main POP file is the one specified in the Input section. Click on View POP to display all the results directly. Here is the Critical Points section, followed by the atomic populations for a standard QTAIM analysis. The output also contains information on the topological structure. This output file contains the descriptors, and its name is shown in the entry field. Please check that the correct file has been assigned to this entry. Then, click on View Output Structure. The molecule is displayed together with the positions of the critical points. Please see the dedicated tutorial for a detailed analysis of these results. Now, we can move on to a new calculation for the ELF analysis. First, let us clear the console. Now, select the ELF analysis using the predefined button. You can see that the command line is automatically modified. The selected function has automatically changed from row to ELF. Now, run the calculation. Good. The calculation starts correctly. You can also see the calculation time, which is automatically reset for each new calculation. Here, we obtain 8 basins. The calculation is now finished. Select the correct output file. Here, I forgot to change the name of the output calculation. So I am going to run it again. Let us clear the console and run the calculation again. Be careful, this is a common mistake. Now, the output calculation has the correct name. We can now view the ELF POP file. Of course, all the results of the ELF calculation are available. The basin populations are given at the end of the POP file. Now, we can display the positions of the ELF attractors. Normally, everything is correctly assigned in the entry field. Here, the XYZ file corresponds to the ELF critical point descriptors. Just check the file name and click on View Output Structure. We can now see the ELF topology. 2 attractors are located below and above the molecular plane. Beginner mode is selected by default. More advanced calculations are available in advanced mode. In advanced mode, many command line arguments are available directly through the interface. There are several sections, including a general section and a critical points section, where you can select the TopChem2 arguments. There is also an additional section for direct molecular visualization, with one-dimensional and two-dimensional modes. This will be explained in another tutorial. To finish, if VMD is installed on your computer, the graphical interface should detect it automatically. You should then have access to VMD, and you can select it using these 2 buttons. The ELF topology can also be viewed with VMD. Just run it. VMD should now open correctly. Good. Here, you can see a typical ELF visualization. You can select the representation mode. You can also modify the isosurfaces. Good. Thank you for your attention, and see you in the next tutorial. Bye-bye.